Okay, we are on page 151, equivalent ratios. There are no math problems to be solved on page 151, so this video will be informational only. Basically what I want you to do is hit pause now and take the next 5 minutes to read page 151. When you're done, resume the video and I will point out to you what I think are the important things. So please pause the video now and resume when you're ready. Okay, so the first thing is I want to read this paragraph with you about equivalent ratios. Our first term of the day is equivalent ratios are ratios that name the same comparison. You can find equivalent ratios by using a table or by multiplying or dividing both terms of a ratio by the same number. So equivalent ratios have a multiplicative relationship. So let's examine what happened here. They gave us an original ratio. It looks like a fraction, but it's a ratio of 2 to 7. And then they double. And what they're doing here, what these arrows are showing, is that we're going to take this first term and we're going to multiply it by 2. If you multiply one term of a ratio by 2, you have to multiply the other term by 2. So you get 4/14. Or you could actually start with a ratio that's not simplified, like 8 and 24, and you could actually simplify it. 8 and 24 as a fraction would be divisible by 4, so you'd divide these by 4 and you'd get 2 to 6. So if you're thinking, that seems a lot like fractions, it's the same idea. It says, the next sentence says, a ratio with terms that have no common factors is said to be in simplest form. Now let's scan ahead. And we're going to go ahead and take a look at example 2. There's a question posed here, and then the book shows you two different ways to solve. One is to use a table, and one is to just read carefully and do a multiplication problem. The question reads, you make 5 cups of punch by mixing 3 cups of cranberry juice with 2 cups of apple juice. How much cranberry juice and how much apple juice do you need to make 4 times the original recipe? And method 1 is to use a table. And I have a feeling if you read this this table, it's going to make a little bit of sense. But if I took some information away, it might be confusing. So I'm actually going to use white ink right here. And I'm going to show you, I'm going to take away some of this stuff right here. And I'm going to put a couple blanks in there as well. And I'm going to show you how to get some of these missing numbers. Let's pretend I didn't know that number, and let's pretend I didn't know that number. So because there's some problems on Moby that look like this. It's just a good concept to get. So remember that we had an original recipe that was 3 cups of cranberry juice to 2 cups of apple juice. Original recipe. And here's what you have to notice. While the number of cranberry juice cups is missing, what's not missing is that this really important piece of information right here, which was how would we get from 2 cups of apple juice to 4 cups of apple juice? And I hope in your mind you think, well, we would double it. So we would multiply that by 2. Well, if you multiply one part of a recipe by 2, you have to multiply the other part of the recipe by 2. So that's what this table is trying to get you to notice, is that the first set, or the next set over from our original recipe, is just doubled. So the cranberry juice would double from 3 cups to 6 cups, and the apple juice would double from 2 cups to 4 cups. Now, some kids think that I just said that you continue to double. And if you look carefully here, you don't actually double. I'm doing this wrong on purpose. 6 times 2 is 9? No, 6 times 2 isn't 9. I actually did that wrong on purpose. So I have to undo. So some kids think, well, how do I get from 6 to 9? Well, actually, you don't have to use the 6 and the 9. You go back to the original number, which was 3, and you just redraw another arrow. To get from 3 to 9, we tripled. And so then what I do is I go back to the original number of apple juices and I triple that. 2 times 3 is 6. And then again, I can go back to the original. I've got 3 cups of cranberry juice and I quadruple it to get 12 cups of cranberry juice, and I quadruple this to get 8 cups of apple juice. So I know that looks a little bit complicated. Sometimes you notice patterns. Looks a little bit complicated. There's actually a second method, and maybe you would have thought to use the second method. I'm going to show the question again. And the real important part of the question is this right here. How much cranberry juice and how much apple juice do you need to make 4 times the original recipe? Well, this right here tells you what the operation is. 4 times an original recipe would be to take your 3 cups of cranberry juice and your 2 cups of apple juice and do what with it? You would multiply each of those terms by 4. And 3 cups of cranberry juice times 4 would be 12 cranberry juice, 12 cups of cranberry juice, and 2 cups of apple juice times 4 would be 8 cups of apple juice. And if you look down at it, method 2 at the bottom, you'll see that that would be the ratio. That's actually the same thing as the ratio on the table too. So you just have to do, basically the concept here is that you have to, when you multiply one part of a ratio, you have to multiply the other part of the ratio by the same number.